Hello and welcome to Otten Math. In this edition of Otten Math, we're going to talk about graphing and writing equations of parabolas. So we take a look at the different forms or the ways that a parabola can look graphically, and we can see that we can either have a parabola that faces up, down, right, or left. So let's take a look at, first we're going to graph parabolas from equations in parabolic form, and then we're going to write equations in standard form from a graph. Then we're going to graph and write equations in different forms for a parabola, so different forms that you can write a parabola. We're going to write equations for those, and then we're going to graph them. Then we want to convert from standard form to vertex, intercept, and parabolic form, or general conic form, and understand the benefits of each. All right, so the basic parent function of a parabola that faces up is y is equal to x squared, where the vertex is at the origin. You notice the two terms here are positive and positive. We're going to have negative and negative, but the two term signs are the same. When the parabola faces down, it's y is equal to negative x squared, or negative y is equal to x squared. When it faces right, it's going to be now x is equal to y squared. So you can see before it was y is equal to x squared. Now this is x is equal to y squared. Both terms are the same, have the same sign. Or a negative and a positive, so negative x is equal to y squared, or x is equal to negative y squared. All right, so let's talk about the definition of a parabola. So we talked about circles. We said the circle is a set of all points that are equidistant from a fixed point called the center. And then we started talking about ellipses, and we said the ellipses were similar to a circle, but now we kind of separated the center into two different points, which we called foci. And now the distance, the sum of the distances from the foci to the ellipse is going to be constant. That's an ellipse. And then keeping that idea the same now with the two foci, we moved on to hyperbolas, and we talked about the fact that the distances, the differences between the distances from the foci to the hyperbola branches is going to be constant. So with an ellipse, it's the sum of the distances, and with a hyperbola, it's the difference of the distances from the foci to the branches of the hyperbola are going to be constant. Right, so now we're going to talk about a parabola, and it's important to understand the definitions of the figure so you can understand how each of the different parts of the figure relate to each other and to the graph itself. So we still, in this case, we still have a vertex, the vertex of the parabola here. We also have a focus, a singular focus. And we have something called a directrix, which is a line. So the vertex is a point, focus is a point, and the definition of a parabola is a set of all points that are equidistant from a fixed point called the focus, and then a line called the directrix. All right, so you can see that this is not really drawn to scale. If I were to draw a line from the parabola to the directrix, and that line segment created a right angle, which means it's the shortest distance between the parabola and the line. That distance would be the same as from the parabola to the focus. So the length from the focus to the parabola is the same as the length from the directrix to the parabola. All right, so we're going to talk about p-values. We were talking about a, b, and c values, but with the parabola we'll talk about p-value. The p-value represents the distance from the vertex along the axis of symmetry, which is that axis that cuts the parabola into two symmetrical halves and that goes to the vertex. The p-value represents the distance from the focus to the vertex along the axis of symmetry. Now, the p-value also represents the distance from the vertex to the point of intersection between the axis of symmetry and the directrix. So I have p units from the vertex to the focus, and p units from the vertex to the directrix. And they're both along the axis of symmetry. All right, so here is the general conic form, or we'll call parabolic form for a parabola. And we've taken y is equal to x squared. Now we've expanded it to include the shift in the vertex, or translation of the vertex, off of the origin. And then we have to incorporate the p-value. So taking the parent function, parabola faces up or down. The basic formula is going to be 4p times 4p times y minus k is equal to x minus h squared, where p is the p-value we talked about, the distance from the focus to the vertex, and hk is the location of the vertex. When the parabola faces up or down, also your axis of symmetry is going to be x is equal to h. Standard form for a parabola that opens right or left, x is equal to y squared is a parent function. 4p times now x minus h is equal to y minus k squared. So the only thing that we've done is we've moved x minus h from being squared to having a value exponent of 1, and y minus k now is a squared value. K still remains with y, h still remains with x, p is still the p-value. All right, so we're going to go through some of these questions. I strongly recommend, I'm going to pause while you get the answers, I strongly recommend that you take a time to graph these to determine the answer rather than trying to do them in your head. I personally graph all of these when I figure out the answers. All right, so I'm going to pause here and get the answer. So here's my graph. Right, so the graph of this parabola faces up. Vertex is negative 3, 7. Axis of symmetry, x is equal to negative 3. Coordinates for the focus, negative 3, 12. And the equation for the directrix is y is equal to 2. So remember, the directrix is a line. It's an equation. So y is equal to something will be your equation for a line. It's not just a value or a number. Okay, you try this one on your own. Okay, so the parabola, this is x is equal to y squared now. Parabola faces right. Vertex is negative 9, negative 7. Axis of symmetry now is y is equal to k, which is y is equal to negative 7. Coordinates for the focus, negative 5, negative 7. And the equation for the directrix, x is equal to negative 13. Okay, I'm going to pause here while you get the answer. Okay, graph faces down now. Negative y is equal to x squared. So graph opens down, vertex 3, 5. Axis of symmetry, x is equal to 3. Coordinates for the focus, 3, 3. Equation for the directrix is y is equal to 7. Okay, so now we're going to write equations in parabolic form. Some people call this general conic form for a parabola from a graph. All right, so I want you to take a moment and see if you can create an equation. So the 4p times y minus k is equal to x minus h squared, or 4p times x minus h is equal to y minus k squared. See if you can write this particular graph in that form. Pause here. All right, so you see that the distance from the center to the focus is 2 units. We know that the graph opens to the left, so it's going to be a negative value. So I move negative 2 units this way, so 4 times negative 2 is negative 8. My vertex is 6, negative 2, so x minus 6, y plus 2. Final equation, negative 8 times x minus 6 is equal to y plus 2 squared. All right, I'm going to pause here while you figure out the equation for this graph. Okay, you can see the distance from the focus to the directrix is going to be 3 units. You can see the parabola opens down. It's going to be a negative value for p. So negative 3 times 4 is negative 12. My vertex is for negative 3. I'm sorry, negative 3, 4. So you'll have negative 12 times y minus 4 is equal to x plus 3 squared. All right, so now we're going to graph and write equations in different forms for a parabola. So just to go back and talk about some of the forms that you might have seen: standard form, vertex form, parabolic form, which is just what we reviewed, intercept form. The first, second, and fourth you should have seen in Algebra 2, in Algebra, probably a little bit in geometry, and then we talked about quadratics and parabolas at the beginning of the semester, the first semester. All right, so we're going to complete the square to convert from standard form to vertex form. All right, so I'm going to move the negative 18 to the side. I'm going to find my c value, which is 16. I'm going to add 16 to both sides. I'm going to simplify the right side, and now I end up with y is equal to x minus 4 squared minus 34. All right, so things we can get from the vertex. Well, we can get the vertex. Vertex is going to be 4, negative 34. Now, we can also convert this pretty quickly to parabolic form or general conic form by adding the 34 and then distributing out any coefficients for y. So in this case, for p is equal to 1, p would be equal to 1/4. Right, we can also get the y-intercept by setting the value of x to 0. X-intercepts are a little bit more challenging. Intercept form is probably the best way to get the x-intercepts. You can find the axis of symmetry, x is equal to 4, orientation, parabola faces up. And then we have a minimum value here at negative 34. So those are some of the things you can get pretty quickly from vertex form. Right, so now we're going to complete the square again. We're going to take an extra step, and we're going to move from standard form to general conic form or parabolic form. Right, so we're going to distribute out the 2 first, x squared plus 14x. Then we're going to complete the square. B over 2 squared is 49. And then I'm going to add 2 times 49 to the left-hand side. I have y plus 98. I'm going to rewrite as a squared binomial. Y plus 98 is equal to 2 times x plus 7 squared minus 104. And this looks very similar to vertex form. Now I'm going to add 104 to both sides. And I get y plus 202 is equal to 2 times x plus 7 squared. Divide both sides by 2, and I have 1/2 y plus 202 is equal to x plus 7 squared. So 4p is equal to 1/8. My p-value ends up being equal to, 4p is equal to 1/2. My p-value ends up being equal to 1/8. Right, so what can we get from the transformational form? Well, we can get the vertex, and in the process we got the vertex, as you can recall, from the vertex form. But the vertex here is -7, -202. Axis of symmetry here is x is equal to -7. We can find a high and low point. If we are to rewrite it in vertex form, we can find the p-value, focus, and directrix pretty quickly from this parabolic or transformational form. Right, so I want you to convert from standard form to intercept form real quickly. So we're just factoring this as intercept form. And now I can tell you that in my parabola, the x-intercepts are going to be 10, 0, and -2, 0. And we can use this now to find the axis of symmetry. And then the vertex from that equation for a line, because we'll know that that midpoint gives us the place where the axis of symmetry goes through. That'll give us the x value for the vertex. We substitute that back in to solve for y for the vertex. Okay. So here again, intercepts 10, -2, axis of symmetry, x is equal to 4. I substitute 4 back in, solve for y. Y is equal to -36. And then for the y-intercept, we can substitute 0 in for x and solve for y. And then we have the y-intercept. Right, so that's it for this edition of Ott in Math. I'm talking about parabolas. Join us next time when we talk about second-degree equations and Ott in Math. Thanks for joining.